In this video, we're going to learn how to use scientific notation to represent very large or very small numbers. We're going to learn how to convert back and forth between proper scientific notation and standard form. And then lastly, we're going to be able to use scientific notation within a multiplication or division problem. So first, scientific notation is a way of representing a very large or very small number. Nobody wants to write out, 10, 20 zeros in front or behind some number and take up a bunch of space. So what scientists do is they take a very large or very small number and they compact it down to a scientific notation. So the way we do this is every number is written to times 10 to the power of some number. This power of 10 is a positive or a negative integer or whole number. So it's a really large number. The power of 10 is going to be a positive number, and it's a very small number, very small number is going to be a negative exponent. The rules for this first digit, the rule is that single digit has to be between 1 and 9. It cannot be 0, and it cannot be more than one digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are appropriate single digits to go in front of the decimal or in the 1 spot. These two can be any digit from 0 to 9. Those don't matter. And it's more than 2 spots too. It's not just the nearest hundredths. It could be more accurate than that. But there's no rules for the numbers after the decimal. But there is a rule for the proper scientific notation. It's got to be between 1 and 9, single digit in front of the decimal. So let's show how we convert to scientific notation, in this case the proper scientific notation. This is a very small number, 0.00000000768. Instead of writing all of that out, we can rewrite it as a number in scientific notation, so it's times 10 to the power of some power. The power of 10 is the same as the number of times you move the decimal place. Now, where do we move it to? We're going to move it to the right, some number of spaces. All I know is that my endpoint is going to be between 7 and 6. That's because 7, being a single digit between 1 and 9, I want that to be in front of the decimal place. If you put the finish line here between 6 and 8, 76 would be bigger than a single digit 1 through 9, so you can't put it there. So you're going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. And if it's a really small number, it should obviously be a negative power of 8. Now what is the number in front? It's 7.68 times 10 to the power of negative 8. And so when someone looks at this number and they see the power of negative 8, they know it's a very, very small number. On the other hand, if you have a very large number, 57,100,000,000, it'd be easier to write in scientific notation, so times 10 to the power of. The decimal point is not written here, but we assume it's always there. It's not written in the number. We assume it's all the way to the right. You got to move it to the spot between 5 and 7. That way 5, being between 1 and 9, it doesn't break the rules of being proper scientific notation. I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So 10 times, and it's positive because it's a very large number. And it's going to be 5.71 times 10 to the power of 10. The next example goes from scientific notation to standard form. So the exact reverse of number 1. This example, 1.68 times 10 to the power of negative 5, negative exponent, you're thinking very, very small number. And because you're thinking that, you're going to move the decimal to the left. That makes the number smaller when you move to the left. So you're going to move it once and then 4 more times. If you move it once around the 1 and then 4 more times, you should expect to have 4 zeros after the decimal. If you move it once and you move it for a total of 5 times, 1, 2, 3, 4, 5, then you should have 4 zeros in front of the number. Please do write the 0 in front of the decimal. It's only the correct grammar for a number that's smaller than 1. And that's it. And it makes sense because the power is negative for the 10, and this is a very small number. Part B, 7.898 times 10 to the power 11th. this is a positive number, so this is going to be a very large number when you're done, so it's going to go to the right 11 times. If you move it once, twice, you have 9 more spots to go because the total is 11. That means you're going to have 7, 9, 8, and then 9 zeros. You can go ahead and move it 11 times and then count, but I prefer to do the subtraction method. If you have 11 times to move it and you move it twice, there's 9 more times, 9 more zeros. This number has commas, this one does not. Very large numbers have commas, very small numbers, less than 1, do not. 3 and 4 deal with operations, mathematical operations. 3 is a multiplication problem, so even if you don't see a times x or a dot, and you just see parentheses, you assume it's multiplication. Here we have a fraction, we know it's division. So the rules are, you multiply or divide the first 2 numbers, like any other time. So for example, 2.5 times 3 is 7.5. The powers of 10, in algebra we learned that the powers of 10, we have the same power when you multiply the base, sorry, not the same power. When you have the same base multiplied together, you're going to add the exponents. So if you have 8 tens multiplied together, and then 3 tens multiplied together, that's a total of 11 tens. So 10 to the power of 11. And that's in scientific notation, because we have 1 digit in front from 1 to 9. That's 7. That works. So we can stop right here and we're done. Number 4, now you're going to divide the numbers. 1.5 divided by 3.0 ends up being 0.5 times 10. Now if you're dividing bases, the inverse happens. You subtract. Students frequently get confused on how to subtract negative numbers. When you do -2 minus a -7, this means the opposite of the opposite. So essentially what you're doing here is -2 plus 7. That turns into 5. So it's 0.5 times 10 to the power of 5. The issue here is this is not in proper scientific notation. This number is not between 1 and 9. So we need to move this decimal to the right of the 5. So our first digit in front of the decimal is between 1 and 9. So it's going to turn into 5 times 10 to the power of. You need to adjust this power now. If you keep it the same, you are effectively changing the number. So think about this. If this is 0.5 times 10 to the power of 5, this is a very big number. It goes to the right 5 times. If I move it right once, there are still 4 more spots to go. That's where the power of 10 comes from. So sometimes you need to adjust from here to here on some of these operation problems. Sometimes you don't. It depends on the problem. So to recap, proper scientific notation calls for a single digit in front of the decimals. That is from 1 to 9. It cannot be 0 and it can't be more than 1 digit. The power of 10 is positive or negative depending on whether or not it's a big or small number. These 2 digits or more digits past the decimal, there's no rules for those. It would be 0 to 9. Remember, put commas in for big numbers, no commas in for the small numbers less than 1. Negative exponent means really small number. Positive exponent of 10 means really big number. These 2 operations, you multiply or divide the first 2 numbers, and then the powers of 10, you're either going to add the exponents for multiplication, or you're going to subtract the exponents for division.